Lamport's mutual exclusion algorithm. Lamport's mutual exclusion algorithm. Lamport's disputed mutual exclusion algorithm proposed by Lamport as an illustration of his synchronization for distributed system. In permission-based timestamp is used to order critical section requests and to resolve any conflict between requests. Their type of message, request, reply, and release are used, and communication channels are assumed to follow FIFO order. A site sends a request message to all other sites together. Their permission enter critical section. A site sends a reply message to requesting site to give its permission to enter the critical section. A site sends a release message to all other sites when citing to critical section. A timestamp is given to each critical section request using Lamport's logical clock. Timestamp is used to determine priority of critical section requests. Smaller timestamp rates higher priority over larger timestamp. The execution of critical section requests is always in the order of their timestamp. For example, let's request from PC3 to PC1 and also from PC2. Same also in queue, so let's request Q1 to Q3 and Q1 to Q2. So next, as we can see, they already reply. P1 reply to P3 and also P2 reply in P3, same also in Q. Q3 send reply to Q1 and Q2 send reply to Q1. As we can see, P3 already entered in critical section and P3 send release into P1 and P3 send release in Q1. So as we can see, Q1 has already entered in critical section, so P1 send release to P3 and Q1 send release in Q3. So once it's done, those process can remove P1 to question the queue so that the end no process has any left or request message in the queue because only these two requests were generated. Algorithm to enter critical section. When a site S wants to enter critical section, it sends a request message request TS to all other sites and place the request on request queue, or TS denotes the timestamp of site S. To execute the critical section, a site S can enter the critical section if it has received the message with the timestamp larger than TS from all other sites and its own request is at the top of request queue. To release the critical section, when a site S exceeds the critical section, it removes its own request from the top of its request queue and sends a timestamp release message to all other sites. Message complexity. Lamport's algorithm requires evocation of 3n-1 message per critical section execution. This 3n-1 message involves n-1 request message, n-1 reply message, n-1 release message. Drawbacks of Lamport's algorithm. Unreliable approach. Failure of any one of the process will halt the progress of entire system. High message complexity. Algorithm requires 3n-1 message per critical section invocation. Performance synchronization delay is equal to maximum message transmission time. It requires 3 n-1 message. First CS execution algorithm can be optimized to 2 n-1 message by omitting the reply message in some situation.